numbers, set of numbers, when we have the same number added to itself several times, we call that operation multiplication. But when we multiply that number by itself several times, we refer to that operation as indices. And let me explain this. When we have something like n plus n plus n in n places, we refer to that as multiplication. So we say n multiplied by n times n. That's what I'm saying. But when we have it like this operation now, that is n times n. You understand now? You know we might have added n by a or anything. But in this instance they are the same. That's why we refer to it as multiplication. But here now, we have it as n times n. That is the same number. We multiply it again by n. And we continue like this. So n times. We call that indices. That is n raised to power n. That's what we refer this operation to. So we call it indices. We can also say n raised to power n. Refer to it as exponent. Now, this n is the base and n is the power or index, as the case may be. And with this, it's a very important aspect of mathematics. There are so many operations that would have taken hours. But with this, by resolving it to indices like this, you can easily get your answer fast. And the tricks involved, that is what we refer to as the rules or laws of indices. Now, let's look at a situation like this. N raised to power a times n raised to power b. Look at this situation. I will give you an example to let you know that this is going to be n raised to power a plus b. There is no special cramming in this. My aim is to make everything so simple to assimilate, to understand. Let's look at a situation like this. 2 raised to power 3. Are you getting that? Times 2 raised to power 5. Now, you can see this is 2 raised to power 3, 2 raised to power 5. Let me multiply this out. It's going to be 2 times 2 times 2. Let me multiply this out. It's going to be 2 times 2 times 2 times 2 times 2. You can see. So by the time I count it now, it will be 1, 2, 3, 4, 5, 6, 7, 8. Straightforward, you can see. So it's going to be 2 raised to power 8. So in essence, instead of going through all this, I would have just said 2 raised to power 3 times 2 raised to power 5 is equal to 2 raised to power 3 plus 5, which is 2 raised to power 8. In the same way, let's look at this. N raised to power a divided by n raised to power b will be equal to n raised to power a minus b. Look at that. So, let me also make it like this. 2 raised to power 5 divided by 2 raised to power 3 will give me 2 times 2 times 2 times 2 times 2 divided by 2 times 2 times 2, which is 2 raised to power 1, 2 raised to power 2. You can see that. So, in essence, I would have done it like this. 2 raised to power 5 divided by 2 raised to power 3 is equal to 2 raised to power 5 minus 3, which is 2 raised to power 2. Straightforward. You can see it saved me. Or if I know 2 raised to power 5 and I know 2 raised to power 3, I can, and I have it as the whole number, I could have broken it down like this and get my answer fast. So that's the essence. So before we go on, channel STEM Cafe, where we make everything science, technology, engineering, and mathematics easy to comprehend, assimilate, fun, entertaining, you know. So once here we make everything, your fear about anything STEM to be a thing of the past. We make everything fun here. So if you have if you have the kind of apprehension concerning any STEM subject, this channel is the right place for you to visit at any time. Any topic in science, technology, engineering, mathematics, just come here. We treat everything just like everyday thing that you do. Whatever, here we remove fear, every form of anxiety or worry. Don't worry. And I'm using this opportunity to invite you to our class, especially for those who have examination around the corner to gain admission into tertiary institutions, even for job, where you know that this kind of little mathematics or sciences might be relevant in the questions. We can practice. Yes, we can do this together. So join us. The channel to join will be given in the description. So you are welcome at any time. For now, we have an intensive class going on for those who have examination for tertiary institution. Even for A levels too, we have A levels, GCE, IGCSE, SAT, all of them. And by the time you join us, even if you have anybody around to solidify the foundation, like when they are in the 9th grade or SS1 or whatever it might be, join. There is space for everybody. It's fun. Come and join us. That's why we call it cafe. Thank you very much. So before I go on, this one is mainly for those who are preparing for tertiary institution. So if you have not been introduced to indices before, you might need to refer to our previous lecture. And if you want to join the class, there is still chance for you. Now, let's look at another situation that arises from the two I have described before. Let's assume we have a situation like this, n raised to power 0. What will this one be? Note, it will always be 1. Any number raised to power 0 will be 1. Any number raised to power 0 will be 1. I want you to look at it like this. Let me say I have 2 raised to power 2 divided by 2 raised to power 2. That's going to give me 2 times 2 divided by 2 times 2. You can see. And we have known from the past that when we have 2 indices like this, we are going to subtract the power of this one from this one. That is, we are going to subtract the power. Let me put it like this. 2 raised to the power 2 divided by 2 raised to the power 2. So from our previous example, we know that this one is going to be, you can see this is 1. That is 2 raised to the power 2 minus 2. 2 raised to the power 0. So try it with any number. It's going to be 1. Because by the time you cut it out, it's going to be 1. So any number raised to the power 0 is going to give us 1. Please take note of that. So any number raised to the power 0 is equal to 1. Now let's look at another situation. When we have n raised to the power 1. Now let's look at another situation. When n is raised to the power 1. Any number raised to the power 1 is equal to that number itself. Is equal to that number itself. Let's look at the situation just like we did there. 2 raised to the power 3 divided by 2 raised to the power 2 is going to give us so you can see is equal to that number. Is equal to 2. So what does that give? 2 times 2 indices make so many things very easy for us. Now let's look at a situation where we have raised to negative power. Let's say we have n raised to power minus n. What does this imply? It implies that we are talking about reciprocal of 1 over n n. N raised to power n. Reciprocal of this whole number, please. Reciprocal of this, that is 1 over m raised to power n. That is what m raised to power minus n is. This minus n brings 1 over everything. Let's look at this. Let's assume we have 2 raised to power 2 raised to power, divided by 2 raised to power 3. 2 raised to power 2 divided by 2 raised to power 3. You can see. Or, okay, I come to that. So it's going to give me 2 raised to power 2 minus 3, which is 2 raised to power minus 1. You can see 2 raised to power minus 1. Now, let me cut it out. I'm going to have 2 times 2 divided by 2 times 2 times 2. Half. So what does that mean? 2 raised to power minus 1 is equal to half. You can see this. When we have n raised to power minus n, we can view it as n raised to power 0 divided by n raised to power n. You can see. And which is equal to n raised to power 0 divided by n raised to power n, which is, and we have established that n raised to power 0 is equal to 1. So this one is giving us 1 over n raised to power n. You can see. So n raised to power minus n is equal to 1 over n raised to power n. If you have n 2 raised to power minus 3, it's going to give you 1 over 2 raised to power 3. That's it. Any number, when you have this, this is the simplest way to explain it. There is nothing to cram in mathematics. Nothing. That's the simplest way to explain it. Now, if we have a number like n, this 5 and 6. If we have a number n raised to power a, and this whole number again is raised to power b, so we are going to have n raised to power ab. That is, this number here is raised to this power. That's what it means. That is n raised to power a now. We now do it again, multiply as in again and again in b times. That's what it means. Let me explain, let me illustrate like this. If I have 2 raised to power 2, are you getting it? I now raise it again to power 3. What is giving me now is going to be 2 raised to power 2 times 3, which is 2 raised to power 6. That is what it is. It's going to give 2 raised to power 6. Let's look at it now. 2 raised to power 2 is what? 4. So 4 raised to power 3 is 64. So 4 raised to power 3 is equal to 64. Now, what is 2 raised to power 6? That is 2 times 2 times 2 times 2 times 2 times 2 times 2. So 2 raised to power 6 is also 64. And that's what this expression is. You can see. So once you have it like this, this is what it means. Now let's look at this. When we have a situation, it's n raised to power 1 over n. Please note, this one is different from n 1 over n raised to power n. This one is different. You understand? Or n raised to power minus n. This is a different situation. You get it now? So what this one means is n raised to power 1 over n is equal to nth root of n. How did we arrive at this? Let's say this one is a. n raised to power 1 over n is equal to a. Now, if we raise a to the power of n, what is it going to give us? So, let's say we have a times a times a to n times. You see, it's going to give us a raised to power n. That's what it's going to give us. Now, in the same way, let's say n raised to power 1 over n times n raised to power 1 over n times is going to give us n raised to power 1 over n raised to power n. You can see. And this is going to give us n raised to power 1 over n times n, which is n. So you can see. So at the end of the day, n raised to power 1 over n is equal to n roots of n. So very easy and straightforward. Please. Now let's look at a situation combining like 2 or 3 of these observations we have made. Let's say we have n raised to power a over n. You know, this one is going to give us n raised to power a into 1 over n. You can see. So that is going to give us n roots of n raised to power a. Simple. So this is the last thing I want you to look at. I think this should be number 7, and this one should be like number 6. Now, as you have seen this, you might see a kind of similarity between indices and addition or multiplication process. You know, in multiplication, in normal addition or multiplication process, when you have a n plus bn, you know, it's going to give you a plus b. You can see. So in indices also, if you have a n raised to power a, n raised to power a times n raised to power b is going to give you n raised to power a plus b. So this kind of comparison makes it fun to handle and makes it easy for you to recall whenever you are working these things out in your examination. And I've always stressed it when we are doing this kind of classes for those preparing for examination. Please read and practice like you are already in the examination hall. And that little time of the examination is going to determine how you will be measured, your grade. Please, don't joke with that. Now, we have a question. 3 raised to power n minus 3 raised to power n minus 1 divided by 3 raised to power 3 times 3 raised to power n minus 27 times 3 raised to power n minus 1. So if you look at this, we have 3 raised to power n minus 1 and 3 raised to power n minus 1 here. We have 3 raised to power 3 and 27 is also 3 raised to power 3. So let me quickly simplify it. But please, if it is in the examination, you don't need to simplify it like this. So this one is going to be 3 raised to power 3 times 3 raised to power n minus 3 raised to power 3 times 3 raised to power n minus 1. So by the time you factorize, it's going to be 3 raised to power n minus 3 raised to power n minus 1 divided by 3 raised to power 3 into 3 raised to power n minus 3 raised to power n minus 1. So simple. Cut. We are going to have 1 over 3 raised to power 3. So you can see how the knowledge of indices has made this one to be easy and straightforward to handle. Now let's look at another one. It says 2 over 3 raised to power n multiplied by 3 over 4 raised to power n is equal to 256 over 729. And here we are asked to find the value of n and n. The only way we can do this is by our knowledge of indices. So from here we can say that 2 over 3 raised to power n into 3 over 4 raised to power n is equal to, this one is 16 times 16. That is 2 raised to power, let me see, 8. That's 2 raised to power 8. And this one too is 81 raised to power 9. That is 3 raised to power 6. And now we are going to develop simultaneous equation, simple one. So for us to do that, this one is going to be 2 raised to power n over 3 raised to power n times 3 raised to power n over, you can see that 4 is 2 squared, 2 raised to power 2 n. And on resolving this is going to give me 2 raised to power n minus 2n, you know, this one and this one, times 3 raised to power n minus n. Is going to give me 2 raised to power 8 times 3 raised to power minus 6. You can see that now. Then I can now say n minus 2n is equal to 8. N minus n is equal to minus 6. So what do I do now? Adding this one and this one cancels. This one and this one is giving minus n. So if I add these two, it's going to give me minus n. And this one is going to be minus 2. So n is equal to, okay, sorry. And this one is going to give me plus 2. So n equals to minus 2. So since I can find n to be minus 2, what does that give me? Substituting this one here means that n minus 2 minus n is equal to minus 6. So bringing this one here, it makes n to be equal to 4. So n equals minus 2. n equals to 4. Very simple and straightforward. So you can also confirm by substituting this into this equation. The question says simplify 6 raised to power 2n plus 1 times 9 raised to power n times 4 raised to power 2n divided by 18 raised to power n times 2 raised to power n times 12 raised to power 2n. You can easily make it simple by saying 6 times 6 raised to power 2n times 9 raised to power n times 4 raised to power 2n. You see? And then we can also make this one 2 raised to power n times 9 raised to power n. We wrote this 18 raised to power n times 2. Okay, this one should be 6 raised to power 2n, please. 2 raised to power n times, this one will now be 2 raised to power 2n times 6 raised to power 2n. You can see. So that makes it simpler for us to handle now. We can start breaking it, cutting it rather. Cut, cut. Then this one cuts, this one cuts. We can now say 6. Let's break this one again. 2 raised to power 2 n times 2 raised to power 2n divided by 2 raised to power n times 2 raised to power n. That's going to give us 2 raised to power 2n times 2 raised to power 2n. So, and that gives us 6. So you can do it several ways by just working it, thinking of how to make it fast. You can still break it further. It might take longer time, it might take a shorter time. You can even look at it straight from the beginning and say, yeah, this is the answer. And you get it. So with these examples, you can see what we are gaining in our classes. So endeavor to join. Kindly like, share, subscribe if you haven't, so that you'll be among the first partaker of any video we drop. And I can assure you that from time to time, we will be dropping more videos. Send questions to us to give us challenges. And then, let others around know about this, especially about the classes. I'm glad, excited to be the instructor today. Thank you very much. Any clarification you need, you will see the channel to do that in the description. You are highly appreciated.